There's Irene. How are you, darling?
Chris, you're not going to call? What do we need?
I'm asking you to take out your slides packet. Presentation packet. What do we call it?
The old one that we just finished?
We're technically not finished yet. Technically. I have a sneaking suspicion you're finding other classes to nap in, Chris. I don't know. I might be wrong.
Oh, we're not having next.
Eric, get rid of your jacket. James, get rid of your backpack. Your belongings need to get tucked away. Huma, get rid of your backpack. We need to declutter because in a moment you're going to have all kinds of materials. You're going to need this real estate. Oh, God, live? God, no.
It's the essential dollar.
All right, Christopher, I know it's going to be hard, but I just need for you to try. For my sake, if you have an ounce of care for Mrs. Callahan, just a notch or two. Thank you very much. All right. Up until now, you guys have been basically what I'm going to call just kind of plugging and chugging in the numbers with the momentum. And what I need you all to be able to actually do now is make a connection where you can see these things in action. So this entire unit has been about momentum. And can anybody please tell me what really is momentum all about? Because it's really about two. Okay, let's be a little more. I'm going to, okay, our change in impulse. Thank you. And that's kind of what I'm looking for here. The formula for momentum is mass and velocity. And what you guys need to know and understand, is mass is mass. We'll be traveling a certain velocity, and direction is going to matter. Now, when you guys are going to be given your materials today, in order to kind of make these connections, there is going to be 3 different types of collision lab bench. But the only way you guys can get to understanding what is happening at your lab bench is for you to explain to me what is the law of conservation of momentum. Please raise your hand. If you know the law of conservation of momentum, what is it? No one knows the law of conservation of momentum. Okay, momentum cannot be creative. Momentum cannot be destroyed, which means all we can do. Are we okay? All right. In a nutshell, all of the momentum that exists before a collision must be present after. And what you guys need to really be working on with these equations is understanding that the sum of the momentum before has to be equal to the sum of the momentum after. The key here also is every single time you have a collision, the momentum has to be conserved. However, your velocity or your kinetic energy may not necessarily be conserved. Why? There are 3 types of collisions. If you don't remember what they are, please flip to page 8 in your packet. Diego, can you give me one?
Collision, elastic collision.
An elastic collision. All right. An inelastic collision. Thank you.
Explosion. I like that. I like that.
Oh!
I'll see you in DS after school.
In order for this magic to happen, you're going to have to make connections from here to there. There are going to be times when all of the objects are stuck together to begin with. Usually with your explosions, everything is going to be stuck together to begin with, which means everything is traveling at the same initial velocity, everything. So your initial velocity here is going to be added up with all the mass that matters. All of it must be there before the collision. When things happen, all right, you can have an object going one direction, another object going another direction, which means when you're done, you're going to have a V1 final. You're going to have a V1 prime, V2 prime, V3 prime, depending upon how many particles you've got going, because they're not all going to be stuck together. So the trick here is to really create all of the scenarios possible given the materials that you have at your disposal. When things are an inelastic collision, that means things are going to come together and do what? If things are inelastic, they're going to stick together, which means your final velocity is going to be the same for everything. Okay, so here, your final velocity is going to be the same for everything, and you're going to have all of your masses stuck together. All right, so you need to kind of map out what's going to be going on with the materials you're going to be given. You're going to be given what's called a discovery lab. Now, there are questions that are there to guide you. There is a complete lab report that is going to be due after the break, so I don't want anybody to be in like panic mode or anything like that. We are in my mind, today we need to know how the materials work, how we can simulate an elastic collision, how we can simulate an inelastic collision, and how we can simulate an explosive collision with the materials that we have. So the only way that's going to work is if I bring you to that little corner of the room and explain what's going on. So with that being said, follow me. You guys who are here, you guys are good. You got front row seats. Is that one track? Good God. All right. I have enough setups for 6 teams. So I think if you divide yourself equally, I think there should be 6 teams of 4. There might be a team of 5. I'm not 100% sure. Number 1, each team is going to need a track. The reason you're going to need a track is because A, there are distances on here in centimeters. So when you are actually, which we're going to be doing probably Thursday of this week, you are going to be quantifying everything that you're going to be observing today. Today, I am only interested in qualitative data. I just want you to be estimating. I want you to be exploring. I want you to be discovering. So right now, I don't really need you to focus on the fact that there's a ruler here. What you do need to focus on are the grooves, because when you do put your 2 carts on your path, this right here guarantees they're going to be basically on a collision course with one another. All right. When you do take your carts, you need to make sure that you take they're actually 2 different carts. One cart has this little silver piece here, which when you actually, if you hit it just right, it creates what's going to be called that explosion. In order to reset it, when you push it back in, you give this a little push too, you'll hear the click and it'll catch onto that piece. Now, you have fronts and backs to both of your cars. Now, if you look carefully, there are Velcro dots on one side only. Obviously, if you get things kind of stuck to one another, all right, you're going to see that the Velcro is designed so that you do get that inelastic collision where things are stuck together. When you guys use this little feature, you're going to actually use a meter stick and you're going to give it a pop, and hopefully you should see things explode in opposite directions. Eventually, what you're going to need to do, though, is take the time to design a data table where you can gather and collect all this data so you can analyze it. Now, I need you to understand that you need to kind of visualize like real life. Like if you're sitting at a stop sign and a car behind you is, texting because they're not paying attention, you can do different scenarios where one car is at rest and then the other car is going to collide. And you get to vary the velocities. If you don't want an inelastic collision, if you turn them around, you'll see that they will bounce off of one another. All right? I'm going to tell you right now, it happens all the time. The car in front of you is slowing down because there's a red light, and then the guy behind you winds up coming along faster. So you need to experiment. Okay, one's going slow, one's going fast. And do you see the pattern? I mean, did you happen to see that basically the velocity from here went to here and the velocity from here went to there? If we look slow. Do you see? It's basically, and that is what, it's the law. It's the law of conservation of momentum. Now, once you start just kind of experimenting with the, towards each other, same direction, then what you can do is experiment with varying the masses of one of the cars. I wouldn't do both, just one. So I have different masses, I have scales and whatnot, because when you do get our final, when you get your different scenarios and different things going on, are you going to need to know the mass of each object? Yes. Are you going to need to figure out the velocity? How are you going to measure the velocity of each object? You need which two things? You need distance and time. And if you're measuring your distance in centimeters, are you going to run into a problem? You are. You need to be sure you convert those things into meters. So what I need today to be about is different scenarios, elastic scenarios, inelastic scenarios, explosive scenarios, at rest, not at rest, same direction, different directions. I need you guys to really explore. All right. So with that being said, one team per track. Be sure when you take the cards, be sure. Always. It's been that way all year, son. These just also happen to strategically.
Technically, there's 6.
Aha!
Yeah. Then go join them. When she gets back.
Let's do end of last week. End of last week.
2 tracks per bench. I need this one over there.
No. No, it's gone.
Our flag is gone.
You can be 2 tracks long, but I need that track over there.
Oh, so we can do 2 tracks in a row. Yeah.
You're not even a part of our group.
Oh, they're leaving. Oh, paper. Yes.
We still have Drake.
That's what you do when you try to replicate us.
Obama just saw that. Obama just saw that.
You need to see.
Eric,
Not on the check.
put your name on it. Put your name on it. Put your name on it. Put your name on it.
I'll hit it.
Put your name on it. All right. Do I only have 5 tracks? I thought I had 6 tracks.
Oh.
All right. Then you're joining. There can be a team of 5. Here. I'm sorry, guys. I thought I had 6 tracks.
Whoa.
Put those back in the corner for me, Eldrick. Thank you.
I was born for this.
Do it. Just do it. No, just stop it.
You need to.
It's Drake.
3.
Whoa.
Sun is down.
Ow, I don't want to go over the track.
Eli. Put your name on it.
We're trying not to do.
Put your name on it.
Yeah, it's like almost like a train
Put your name on it.
No, here. Give me my.
Put your name on it. Huma, put your name on it. Iqbal, put your name on it.
Down a track? Probably just a silly song.
Wait, we need a wall.
Wow.
I was like,
New
Jersey Turnpike. This is me in the morning. This is Main Street. This is Main Street. This is LeMoyne Avenue.
LeMoyne Avenue. This is a kid. Whoa! Miss Callahan, how fast do you think we can
Here,
rail
Masa,
these
can I
down?
have this one? Thank you.
You're thinking
No,
Drake?
not Drake. Anything but Drake.
Only because he's broken.
Oh no, aren't we all?
No, Drake.
Can we replace?
I'm going to let you go with the one long track, but I am limiting you to 2 cars because I don't want to skew your results. Thank you.
Hero.
You need to fix your explosion.
That's
Wait, can we do it again?
let's do it again. But let's add more mass. The most mass.
Oh my god. So this ricochet.
But think about why would that one go and that one not move so
That's like
much?
if you get hit by a truck.
Because of the mass.
Like a Honda hitting a truck. Or like a Mini Cooper hitting a truck. Oh no, like they're
1,000
together.
grams on this baby.
What is that?
1,000 grams.
Ooh, I did this one. I did this one. Or,
It's not.
This is Callahan.
Okay, we're done.
I'm kind of confused what we're supposed to do. Are we like trying to find like the momentum?
Right now, I want you to get a qualitative idea of what's going to just about, yes. Because on Thursday, the chaos that's happening now, no.
That's Callahan.
Eye on the target. And in theory, if this has a lot more mass and this explodes, this should go fast and this should just go a little bit. So I'll let you practice and maybe put more mass on here.
Those? They used to tell me so.
And see, that traveled a much greater distance. So what's going to happen is on, like, you'll say, okay, this is at the 55, and then
Let's see how far you can travel.
right.
Yeah, but like, is it going like over?
Well, no, then you can stop it and you can figure out what the velocity is, which means somebody needs to time this one and then somebody needs to time this one.
Oh, then just
Are you seeing it? It's not that bad. No, it's fun too.
Oh, okay, now it's over. It's over.
Why? Why did they fly out of your car?
They weren't.
Thank you, Ramazan.
That's a difference.
Now, just based on that, you can tell that one was going faster than the other one. Okay. And you're supposed to have.
Use like a. Yeah, we have.
Okay.
They're wrong sides.
You need seatbelts.
Use the pencil. I think with the pencil.
Let's go.